Imagine a world where trees grow, die and fall, but never rot. For millions of years, their remains pile up, untouched by decay, until a single lightning strike ignites fires so massive they dwarf anything we've ever seen. This isn't science fiction. This is Earth, 300 million years ago. Welcome to a forgotten chapter of our planet's history, a time when trees didn't rot. Today, when a tree falls, it's broken down by bacteria, fungi, and insects within years. But during the Carboniferous period, something extraordinary happened. Trees evolved a tough material called lignin, the stuff that makes wood rigid. But the microbes that could break it down didn't exist yet. The result? Fallen trees just piled up for millions of years. Let's dive into this wild chapter of Earth's history and uncover why it happened, what it led to, and how it shaped the world we live in today. About 360 million years ago, Earth was a hot, swampy place. The supercontinent Pangaea was forming, and the first true forests were taking root. These weren't your average oak or pine. These were giants like lepidodendron, towering up to 100 feet with scaly diamond-patterned bark. What made these trees special was lignin, a complex molecule that gave them strength to grow tall and compete for sunlight. Think of lignin as nature's rebar, reinforcing the tree's structure. But here's the catch. Lignin was a brand new invention in the plant world, and nothing, not bacteria, not fungi, had figured out how to break it down yet. Today, when a tree falls, microbes like fungi and bacteria get to work, turning wood into soil within a decade. But in the Carboniferous, these lignin-digesting microbes hadn't evolved. So when a tree fell, it just stayed there. Imagine a forest floor covered with layers upon layers of fallen logs, branches, and leaves, piling up over millions of years. These swamps became graveyards of wood, preserved in waterlogged, oxygen-poor environments. It's like the Earth was hoarding its own firewood, waiting for a spark. And that spark came, often. During the Carboniferous, Earth's atmosphere had way more oxygen than today, up to 35% compared to our 21%. More oxygen means fires burn hotter, faster, and bigger. When lightning struck these massive piles of dry wood, the result was catastrophic. Imagine firestorms so intense they made modern wildfires look like campfires. These blazes didn't just burn, they reshaped entire ecosystems. And the leftovers, charcoal and ash that would eventually get buried, contributing to the coal deposits we mine today. All that undecomposed wood didn't just disappear. Over millions of years, these piles were buried under sediment, compressed and transformed into coal, huge deposits that powered the Industrial Revolution and still fuel parts of the world today. This process also pulled massive amounts of carbon dioxide out of the atmosphere, locking it away in the ground. The result? Earth's climate cooled, paving the way for the next chapter of life. Eventually, fungi and bacteria evolved to break down lignin, and the age of indestructible wood came to an end. The Carboniferous period was a strange and wild time when trees ruled the earth, untouched by decay. Their legacy lives on in the coal we mine and the climate we inherited. It's a reminder of how deeply connected our planet's past is to our present, and how even the smallest microbes can change the course of history. If you enjoyed this dive into Earth's deep past, hit that like button, subscribe, and let me know in the comments. What other ancient mysteries should we explore? And don't forget to subscribe for more epic science stories.